We are now recording. We've been a few days without, or I think we were a day or two without recording because my loaner computer died. And so I went by late yesterday afternoon and picked up it isn't the original computer, but it's one pretty much like it. I mean, almost identical. What they did, I think he said he cloned the hard drive from mine and put it into this one. So it's intact. The other one was breaking apart. So this isn't my original, but it looks much more like it. It's more like my other. They were both Fujitsu's, but that was a different model, and it had some things that didn't do well. This one, so far, knock on wood, is doing a little bit better. So this will be mine from now on, so it's good to have this back. Since I had a date, last Tuesday I couldn't record, could I? Wasn't I using the... Yeah, okay. So let me go over any announcements I did then, since so many people are not here right now. Number one, tomorrow, Friday, normally I have office hours on the Birmingham campus, 7:45 to 11:45. I had to get a different car, and I got the plate off the old car, the license plate off the old car, and need to transfer it to the new car, but the only time I can do that is on Fridays because I'm working all the rest of the time the place is open. I had planned to do that tomorrow after I got off work. My wife said, I don't think you want to do that because 1 o'clock there may be a huge line. You may be there the rest of the afternoon. She said, you need to go there first thing in the morning. Well, I don't have any classes in the morning, so I checked with Dr. Pruitt yesterday. He's my immediate supervisor. I asked him, he said, by all means, go and get it done first thing in the morning, then come to campus. So I don't know what time I'll get to campus tomorrow. It won't be at 7:45 because the license place doesn't open until 8, and that's at the courthouse. So I'll get there before 8, knock on wood, and then hopefully it'll be near the front of the line. Hopefully it won't take too long for them to do it. Then I'll be out of there and back on campus. I'm guessing 9:30ish, okay? Maybe 10, depending on how long it takes. I don't know how long it takes. I've never done this before. I've gotten tagged before, but never exchanged a tag. So I just, in the bottom of my heart, I think there's going to be something, oh, you need this, and I'm going to have to run back home and get it or something like that. I hope I'll have everything I need. So I'm guessing 9:30ish, maybe 10, and whatever time I get there, the next 4 hours I'll be there, okay? So I just can't tell you when that will be. Okay. So again?
They basically just ask you for your car, registration, the tag number, the other one, your driver license to make sure you're the owner.
Right.
And that's it.
Well, they also need the bill of sales.
Bill of sales?
See, that's why I didn't know, because I sold the other car. And yes, I did not know that. So I had to email them and get them to send me. Well, actually, I called them and they emailed me the bill of sales. I said, are you sure they'll take this? Yeah, we've done it before. That's one reason there's a delay. And the other thing, I need all the information from the new car and all the information from the old car. Bill of sales has everything from the old car, and I have to take in all the stuff from the new car. And I'll take the tag in too, so they can see physically that is the right tag. So hopefully I'll have everything they need. I'm with you. I'm hoping that'll be enough. Okay. All right. Now, that takes care of Friday. Ilsa's here.
This seems to be a popular trend.
What's that?
This seems to be a popular trend.
Yeah. Yeah. Right. You double the class size every time, don't you? Yes. Okay. All right. The next bit is the good news. I'm doing all the announcements because I've got my computer back, so I'm recording again. So in case other people, which a lot of them are not here, if they want to hear these, they got them. The other thing is next week, sad news, hold this up, is Thanksgiving week and there are no classes. Oh, hey. Okay. No classes. Nice for you to be happy over Thanksgiving, but about no classes, that's really sad. So anyway, no classes next week. If you have business at the college, All the offices will be open. They may not be fully staffed, but they will be open. You can take care of any business on either campus you need to. Some instructors, some administrators, probably most of the administrators, some of the staff will be down in Montgomery at the professional meetings down there. I didn't want to spend the money, so the department's money to go down there, so what was that? So I will be on campus, and many of the other instructors and employees will be on campus. However, they have professional development for us on the Birmingham campus. So Monday and Tuesday, I'll be on the Birmingham campus. I probably will be fairly inaccessible because I'll be in the meetings. They usually let us go relatively early, so I may be in the office the latter part of the morning. Latter part of the afternoon. My office over there, you can check on the syllabus where that is. Wednesday, we're back in our offices again. So I'll be back on Bessemer campus on Wednesday. So if you do need to see me, that would be the best day to try. Okay? Check with your instructor. If you need to see someone next week, especially if it's an instructor, check with your instructor this week to see if and when they're going to be on campus, which campus, all that kind of stuff, when they're available, when they're not. Check with that first. Don't assume. They may be in Montgomery, Monday and Tuesday, so you may not be able to catch them at all. So check with them this week before you plan to come next week. If it's an office, you can come Monday or Tuesday or even Wednesday morning and take care of any business in the office. The reason I say Wednesday morning, number one, a lot of people take personal leave on Wednesday, so they're going to get on and start cooking the turkey, But not everybody does. I'm not planning to anyway. But usually sometime afternoonish on Wednesday, the administration will send out an email, okay, everybody can leave early today. Now, they won't ever say when they're going to say that, what time it's going to be. I think I can remember one time it was as early as noon, and last year it seemed like it was around 2. So it just depends on the whim of the administrator who's in charge of if they let us go, and it's not guaranteed, and when they let us go. The point being, don't plan to come catch us on Wednesday afternoon. The odds are you won't be able to catch it, or you'll catch them on the way out the door or something. So if you have business to do with the college, get it done Monday, Tuesday, or Wednesday morning. That will be safest. Some of us will still be around sometime into the afternoon on Wednesday, but not very much. Okay. Any questions on anything before we move on? Say that again? This Chapter 5 test? Okay. Technically, we haven't finished Chapter 5. Today, we should finish Chapter 5. So it'll be 1 week of class from today. So in other words, Thursday after Thanksgiving is when technically it's due. If you need more time, you can have it. Now, this came up in the last class, so let me say this. I'm glad you asked that. Number one, after we get back from Thanksgiving, we have 2 weeks of classes. 2 weeks of classes, then the week of finals. Okay. In this class, your final will be a take-home. And in fact, it will be 2 pieces. The first piece will be Chapter 6 test, whatever we cover in Chapter 6 up to that point, it's going to be a 1-page, probably 10-question test. Your final exam, which is comprehensive over all 3, will be 1 page, probably about 10 questions on it too. So they'll be much shorter than the first 3 tests have been, and you can get them both done, hopefully within a week. Okay, because that one you got to have it in, and that one's technically due the Thursday of finals week, but I'll take it any day you get through with it. Want to turn it in, you can. But I have to have it by the end of business on Friday. And remember, my end of business on Friday is usually noonish on Friday, because I think grades have to be in maybe by noon on Monday. So I need those in sometime during finals week, both those class tests. All right. Now, one other thing, I'm going to put this on Screencast-O-Matic too. I believe they've already opened student course evaluations, right? Okay, have you already done them? No. Okay.
This morning.
What's that?
Oh, yeah, I didn't do that. I just saw it.
Okay, yeah. Please do them. If you want to wait until after you see your grade, you can. But the trouble with that is at the end of the term, quite often, it's over. Dump them, shape the Etch-a-Sketch. Everything goes blank. You forget about it. So don't let that happen. If you're afraid you're going to forget about it, do it earlier. Yeah. The odds are not much is going to change between now and then. I've been told 5 minutes, 10 minutes. That's about all it takes. Is that what your experience is? 2 or 3 minutes to do. Okay. Now, they do ask, not just for the course, they do sometimes ask for other things too, like food service, library, registration process. Please do those as well.
I haven't eaten the food here.
Yeah, I don't think they really do food service, but something like that. Maintenance, grounds, whatever. So if they ask for another survey, please do those, because I get feedback from you every day by just, asking you questions and interacting with you. Those folks, sometimes that's the best feedback they get. Please do those as well. But I'm a department chair. I use the student course evaluations and doing evaluations of my instructors under me. Full-time, part-time, I have a stack of them, and I print off the student course evaluations they've had in the last year. That's what I go by. So please, we do look at them. We pay attention to them. I look at my own to see areas that I see from you that you think I need to improve. So please do the student course evaluations. All right, any other questions? Okay, we did this slide last time. This is the sum to product formula, which are perfectly fine, and in my mind, not worth memorizing, okay? I don't even go back through how you get them, okay? Because they're so seldom used. If you are doing an integration, it's far easier to integrate this and integrate that than it is to do all this math, okay? So I can't think of any very practical use for these at all. Maybe there is, I just don't see. There is an example here. That's what we're going to do now. So let's do the example 8 here. Okay, let me get my pen situated. Oops. This thing is very slow. Okay. Find the exact value of cosine of 195 degrees plus the cosine of 105 degrees. Now, I know that's something you need every other day, right? Very frequently you need to know what that sum is, okay? So, using the sum to product formula, which we had on the previous page, on the previous slide, which one of those 4 is it? 1, 2, 3, or 4? You have that page in front of you? If not, it's number 3. Okay? Yeah, okay. It's cosine u, I'll write it down, cosine u plus cosine v is equal to, because I don't believe in memorizing this mess, 2 times cosine u plus v over 2 times the cosine of u minus v over 2. All right. Now, goodness, one thing I just noticed, the screen is all, someone put tape or something on it. All right, using that formula, what would be this cosine of 195 degrees plus 105 degrees? Well, obviously a factor of 2. The cosine of, now what's that first? The first is the average of these two. Add those together and what do you get? Second, 300 divided by 2 is the cosine of 150 degrees. Okay? And the second is the cosine of, say again, 90 degrees. The difference between those two, well, the difference between the two is 90. Half the difference is, yes, is 45 degrees. It's cosine of 45 degrees. Okay? So this is 2 times, what is the cosine of 150? Where are you, Waldo? Second quadrant. And what's the cosine in the second quadrant? Negative, okay? It's negative in the second quadrant. So this is going to be a negative value. What is the reference angle for 150 degrees? 30, okay? Because that's how far you are from the nearest horizontal axis, which is 180, so you're 30 away. So it's going to be the negative, the cosine of 30. What is cosine of 30 degrees? No, that's sine of 30. Square root of 3 over 2. Okay, times, and what's cosine of 45? Square root of 2 over 2. Okay, now this is not going to be too bad. The one set of 2's will go out, and that leaves you with negative root 6 over 2. Good for them, they got it right too. See how that works? Any questions on it? All right. So, now, this may be a little more practical example of this. I'm not swearing that it's very practical, but what if you had an equation that was something like this? Solve this. Solve sine of 5x plus sine of 3x is equal to 0. How are you going to do that? Well, basically it's up to a different formula. It's the first one on the previous page. Please. What's that? Okay, say that again.
Having it equal to 0 doesn't change anything.
No, the left-hand side you do just like you did before, but then you got an equation, then you set it up and go. And besides, this one is not an angle, it's got a variable in it. So you're solving for x here. The other, it was just finding the value of the angle because they gave you numbers there. So this will be, we're going to use the first one of those, which is sine u plus sine v is equal to 2 times sine of u plus v over 2 times the cosine of u minus v over 2. Okay? So this one will be what? 2 times the sine of say again? Okay. Okay, 5x plus 3x is 8x, okay? So that would be sine of 4x times the cosine of x. And that's equal to 0. Okay? Now, you got 3 factors here. Obviously, 2 will never be 0, right? Not in this universe, okay? So we could divide out the 2 or forget about it, throw it away. I don't care what you do with it. It's not important for the rest of the problem here. But here we have that either sine of 4x is equal to 0 or cosine of x is equal to 0. Now, they didn't give us any limitations here, so you have a whole bunch of possibilities here. Okay? Let's start with the sine. Let's first solve for 4x. What would be possible values for 4x? where is sine equals 0? That's 0. And what? Okay, you're thinking in degrees, which is fine. They usually think in radians. 0, pi, 2 pi, 3 pi, 4 pi, negative, yeah, all your pi's. Normally you would say 2 pi, but you see the zeros happen every pi. This one's going up, that one's going down, up, down, so it's every pi. So this will be 4x is equal to n pi. Make sense? Okay? So therefore x is equal to, divide both sides by 4. So it'd be, however you want to write that, n pi over 4, or n times pi fourths, or whatever you want to say. So that is your part for your sine. Okay, how about cosine? Where is cosine equal to 0? All of your half pi's. And since those are exactly pi apart too, you can say pi halves plus n pi. Okay? So basically, every full and half pi, those are the possibilities here. Okay? So you can actually shorten, well, let's see. There is a better way to say that. That would be pi halves plus n pi halves over 2. In fact, because here you have at 0, pi, 2 pi, 3 pi, and this has pi halves, 3 halves, pi, every other thing. So just say pi halves plus, well, just say n pi over 2. And that will work.
Because
every half pi, n pi over 2. That would be the shortest way to give the answer. So the total answer would be n pi over 2. N equals 0, you got this one. N equals 1, you got that. N equals 2, you got, so, wait, no, that's not right. Whoa. Where's my brain here? I was thinking this. N pi over 4. That will cover every one of them. N pi over 4. Sorry, I forgot that we divided by 4. Duh. Okay. Okay, certainly that'll have every one of these, but it also covers every one of these. Because 2 pi over 4 would be pi half. 4 pi over 4 would be, So that's going to cover them all. All right. Here they come in with a bang. Okay. Okay. She's mad at that door. Okay. All right. Double the class size again. All right. 2 people came out. All right. We just finished the example 9 on page 387. Okay? And we saw our answers were, this one covers it all. Because all your half pies are covered by this, and all your quarter pies are covered by that, obviously. So that's your final answer. By the way, there's checkpoints after every problem, and the audio-video solutions for all your checkpoints are at larsonprecalculus.com. Okay, never mind. There is, any questions on this before we move on? Okay? There is one application given here, so let's move on to the application. And here it is. Ignoring air resistance, the range of a projectile fired at an angle theta with the horizontal at an initial velocity of v0 feet per second is given by this formula. R being the range, which you can think of, that's your x value, horizontal displacement, is 1/16 V0 squared, V0 being the initial velocity, V0 feet per second, sine theta cosine theta. All right, now, notice this is in feet per second. You might say, where's that 1/16 come from? I'm not going to tell you completely because that gets into physics and you have to do a bit of stuff, but I'll tell you what it's related to, okay? It's related to 32, okay? It's exactly, 16 is exactly half of 32. What difference does 32 make? In the U.S. customary system, feet, system, the acceleration due to gravity is 32 feet per second squared. So that's where the 16 comes from. What's that? 9.8 is meters per second squared. Okay? That's why I said it depends on the units you're in. SI units, that would be basically 1 over 19.6, okay? Or something like that. In the U.S. customary system, it would be 1 over 16. Okay. Now, even though this is U.S. customary, we still do our thetas in radians. That's not anything to do with SI or otherwise. We just about do everything in this in radians. Okay. So ignoring air resistance, the range of a projectile fired at an angle theta with the horizontal. Watch it. They'll give it in degrees. It really doesn't matter. Okay. Most of the time, though, in calculus, you use radians. Initial velocity that where theta is the horizontal distance that the projectile travels, and r is if theta is your angle of elevation. All right. Now, here is the problem. A football player can kick a football from ground level with an initial velocity of 80 feet per second. Pretty good. Write the projectile motion model in a simpler form. Okay? Write the projection motion model in a simpler form. Well, here's what they mean. Your projection motion model was R is equal to 1 over 16 times V naught squared times sine theta cosine theta. Now, what's not simple about that? What could be simpler? Second?
You said everything.
I can't hear. Sorry.
She said everything.
No. Well, the main thing that you got both a sine and a cosine in it. So if you could have only one trig function, that would make it a little simpler. Okay, now, hats on. The sine theta, cosine theta show up somewhere in one of our identities. Which one? It's a double angle formula. Sine of 2 theta is equal to 2 times the sine theta cosine theta. Ooh, I almost ran out of room. I did run out of room. Remember that? Okay. Well, this is a product, that's for sure. And then you're doing, but no, okay. No, here's the reason. Because the thetas are the same. If the thetas were different, you would use that. Notice that's U and V. Okay? This is the same theta, so you wouldn't use that. Turn back a little further, as in page 382. Well, it may not be that page in yours because you have a new one. The sine 2 theta, or sine 2u, is equal to 2 sine u cosine u. Right? What's that? The double angle formula is on the very first page of 5.5. You see it? Okay. See the first one there, sine 2u, or sine 2 theta is equal to 2 sine theta cosine theta. That's the one we'll use here. Okay? So, we need to take half of what's here and write 2 sine 2 theta instead. Right? Well, if we take half of 1/16, that would be 1/32, wouldn't it? Ugh. Okay, so this would be 1/32 V naught squared sine 2 theta. By that? Because if you put instead of sine 2 theta, 2 sine theta cosine theta, you get exactly the other. So that's the A part, write the projectile motion model in simpler form. That's a little bit simpler. You only have one trig function. Now the question is, at what angle must the player kick the football so that the football travels 200 feet? What does 200 feet represent from this equation up here? That's your range, right? At what angle must the player kick the football so that the football travels 200 feet? They've already told you what his initial velocity was. That's 80 feet per second, right? So it's looking for at what angle, theta, would it get 200 feet? That's your range, R. So that, therefore, we put that in. 200 feet, I'm not going to put it into units, is equal to 1/32 times 80 feet per second squared times the sine of 2 theta, right? Plugging in that and this in the appropriate places. All right. Now, I really don't care what order you do things here. I sort of do a little bit. Let's go on and square that. That's 1/32 times 6400, right? Times sine of 2 theta. All right. The reason I did that is 32 will go into 64. 2 exactly. So that would be 200 exactly. Well, now, we divide both sides by 200. And what we have is 1 is equal to sine of 2 theta, right? Say again? I divided by 200. No, it's not 2 times the sine of theta, it's sine of 2 theta. You can't divide inside that. You have to solve for inside that, then do your division. Sort of like we did that last example. We had a sine of 4x, remember? You solve for 4x, then divide by 4. Solve for 2 theta, then divide. So, at what value, at what angle 2 theta is your, well, at what angle 2 theta is the sine equal to 1? Pi halves. Okay, so this would be 2 theta is equal to pi halves. Or you can do, and I'm sure the book does it, 90 degrees, right? I don't care which way you do it. Okay, now divide by 2, and what do you get? Theta is equal to either pi fourths, not pi, you're dividing, not multiplying by 2, dividing by 2, or 45 degrees. Now, by the way, what is 200 feet? 66 2/3 yards. 66 foot and 66 yards and 2 feet. Nick is wanting to call this guy, okay? Okay, yeah, let's sign this dude up, okay? If he can kick field goals 60-some yards, I want him. Okay. What's that? That almost looks like the professional one for Vikings, Minnesota Vikings, or whatever they call themselves now. It could be Miles College, maybe. Is that their college? Do they have a football team? I think they do. Boy, let's get their punter. I mean, their field goal kicker. All right, 66 yards is pretty good down the field. Okay. But he has hit it at 45 degrees. Now, I don't know if you've seen this before. If you do anything less than 45 degrees, then you don't get enough height. You don't go as far. 45 degrees, that gives you your maximum, because you get over 45, it goes higher, but it comes down short. So actually 45 degrees is the optimal angle to kick. That's as far as he can do if he could kick at 80 feet per second velocity. Okay. Now, I know he's doing his angles in his head, right? No, never mind. Actually, they kind of do, without really thinking about it. If they got a short field goal or extra point, they're going to kick that thing pretty high to keep it from getting blocked. When they're going for the long ones, they got to go close to 45. That's more likely to get blocked. Well, never mind. We won't get into football. But, yeah. So, let's see. Let me clear. In fact, I think I can just go to the next page. Yeah. You can use the double angle formula to rewrite the projectile model to be, if you multiply by 2 and divide by 2, you get 1 over 32 v naught squared, 2 sine theta cosine theta. And that's exactly sine of 2 theta. So there's your simplified model. Then you plug in, you write it again because it was so much fun writing it the first time. And once you've written it again, then you can plug in 200 for your range, 80 for your initial velocity, and do the math, and that gives you 200 is equal to 200 sine 2 theta. Divide both sides by 200, you get 1 is equal to sine 2 theta. 2 theta must be, oh, they did use, I thought for sure they were going to go back to degrees, but pi halves, so theta would be pi fourths. So he's going to kick that at 45 degrees. I knew they were going to go back to this. He must kick the football angle 45 degrees so that the football will travel the 200 feet, which is close to 67 yards. Whoa. All right. Of course, traveling that far doesn't mean it's going to cross the goalpost from that far away. Because remember, the bar is higher, and you got 10 yards into the end zone, and he's so many yards behind his center, that front line of scrimmage. So it's not quite as impressive as it sounds, but it sounds like a pretty good kicker. Okay. That's it. End of the section. End of the chapter. Okay. Let's go over vocabulary now. Fill in the blank to complete the trigonometric formula. This is from an identity. Sine of 2 theta is equal to? Say again?
I said what we just did.
Exactly. And what was that? That it's u. Sine of 2u is? 2 sine u cosine u. Exactly. Cosine of 2u is? And you actually have 3 that you could choose from here. You could do any one of the 3. Oh, I forgot to mark Justin down. Okay. Now we finally have enough for a basketball team. Okay. What is cosine of 2u? There are actually 3 of them. Give me any one of them. Anyone recall? Back on the very first page of this section. Okay, either cosine squared u minus cosine squared u, that works. And Jeremy's here. All right. And there are other two also. Okay. Number 3, 1 minus cosine 2u over 1 plus cosine 2u is what? That's on your power reducing formulas. Around page 384. Is what? Tangent squared u. Number 4, sine of u over 2, that's your half angle formula, is what? Excellent. Okay. Sine u cosine v, different functions this, that's your product to sum formula. Sine u cosine v is 1/2 sine of u plus v plus the sine of u minus v. Okay? And cosine u minus cosine v would be cosine u minus cosine v. This is sum to product formula. Sum to product formula. Last one. What did you say? Oh, where are you getting that? You're doing the product, I think. This is a difference. Cosine u minus cosine v. Not, you were doing product to sum, this is sum to product. Last section, last little block on in the chapter. Huh? Okay, it's the in the old edition of page 386, between example 7 and example 8. You got a block there? Cosine u minus cosine v? -2 sine u plus v over 2 times the sine of u minus v over 2. Good deal. Now, homework exercises. Any of the odds 7 through 13. Any of the odds 15 to 19. Do either 21 or 23 or both. Do 25. Any of the odds 27 to 31. Do either 33 or 35. Either 37 or 39, either 41 or 43, or both on any of these. Either 45 or 47 or both, either 49 or 51 or both, either 53 or 55 or both, either 57 or 59 or both, either 63 or 61 or 63 or both, any of the odds 65 to 71. And then number 73 is one very similar to, it's one describing what you saw in the figure on at the very beginning of the chapter on page 382 or thereabout. It's just the planes going in the opposite direction. I do not know why. I think it's exactly the same picture. They just reversed the left to right of it. So try to do 73 and or 75. I'll let you choose which of those two or both you want to do. There is a true-false 77 you can look at and make sure you understand it. And then there's one on complementary angles that you might want to review. Okay, chapter summary, completely up to you. All your formulas are there pretty much. So there's 2 pages. Yes. Oh, yes, sir.
Sorry, Dr. Fowler. I'm not going to be on campus. Can I show you something real quick?
Okay. I was recording for most of that, but I must have hit the wrong key when I was talking then. Okay. Chapter 6, Additional Topics in Trigonometry. 6.1, The Law of Sines. basically, what we've been doing up till now has been either unit circle trig or right triangle trig, right? Now we're going to get into any angle, any triangle. Especially one that is not right is called an oblique triangle. Now don't get that confused with obtuse triangle. Or obtuse means greater than 90, okay? Oblique means not 90, okay? So an oblique triangle, the largest angle is either less than 90 or greater than 90, okay? So we'll use the law of sines to solve oblique triangles, triangles that are not 90 right triangles. Now, law of sines does two ones, AAS or ASA. What in the world do we mean by that? That's, yes, if you know two angles and any side, you can use the law of sines. Okay? Or, if you know two angles, well, this is really the same thing. Two angles in any side, you can do law of sines. Okay? We can also do law of sines if we have two sides and an angle not in between those two sides. Two sides and then one of the other two angles, but not the angle in between. And always say side-side angle. Never angle side-side. Okay? Never mind. Okay, she caught it. Okay. Now, we'll find the area of oblique triangles. Okay? It's not using the law of sines, but it looks enough like it that we'll do that then. And we'll use the law of sines to model and solve some real-life type problems. Okay? So, if that wasn't introduction enough, let's go to the introduction. Okay? As I've already said, in this section and the next section, we will solve triangles that are not right, that contain no right angles. These are called oblique triangles. For the largest angle, I don't know which it is, probably A here, is less than 90 degrees, or when it's greater than 90 degrees. Those are your oblique triangles. They have no right angles in them. Okay. As standard notation, we'll name the three angles capital letters A, B, and C. Those are going to be the angles. And we'll name their opposite sides little a, little b, and little c. Okay? The side opposite those three angles. So we're getting away from thetas and alphas and betas and things like this. Capital A, B, and C for your angles. Lowercase a, b, and c. But always make sure they're the opposite side to the corresponding angle. To solve an oblique triangle, we need to know the measure of at least one side, okay, and any two of the other measures, either two angles or a side and another angle, or all three sides. You can use all that, either two sides, two angles, or one angle and one side. You got to have one side, and then any one of those situations. Two sides, that's going to be law of cosines if you know all three sides. A side and two angles, that's going to be law of sines. One angle and one side, some of those cases would be law of sines and some will be law of cosines. So that is the one that you have to be careful where the angle is. Okay? So this breaks down into four cases. If you have two angles at any side, that's angle, angle, side, or angle, side, angle. Any of that, law of sines. Two sides and the angle opposite one of those sides, that's your SSA, that's going to be law of sines. But if you have three sides, you cannot use law of sines. You have to use law of cosines. Two sides and the angle in between those two, you cannot use law of sines. You have to use law of cosines. So the first two of these are law of sines, the last two, law of cosines. Okay? Don't worry about law of cosines yet. We're going to get to that in the next section. So here is the law of sines. I'll give you a little bit of background here. Okay? If A, B, and C is a triangle, A, B, C is a triangle. Okay? That names the vertices of that triangle. Okay? It's also the angles for that triangle. And the side opposites are A, B, and C. Little a, b, and c. Okay. Now, before we get to that, let's observe some things we do know. Okay? If you were to drop a perpendicular down from C, okay? If you draw AB horizontal, drop a perpendicular down to AB from C, you're forming a right triangle, a right angle there, right? Because it's perpendicular to AB. Well, now you have two triangles that are right triangles, okay? And you know these relationships. Let's start with angle A here. You know that the sine of angle A is H. You tell me. Sine of angle A is H over B. Okay? Now, the sine of angle B would be H over A. Okay? Well, let's solve both of those for H. If sine of angle A is H over B, multiply both sides by B, and you get H is equal to B times the sine of A. Right? Let me write that down. Ooh, let me get my pen activated. All right. What we have is sine of A is equal to H over B. And we also said that the sine of B is equal to H over A. Well, let's solve this for H, which means multiply both sides by B. So you have H is equal to B sine A, right? And over here, multiply both sides by A, and that gives you H is equal to A sine B, right? Those are the same H's. It's the same triangle, right? So if that's true, then B sine A is equal to A sine B, right? Okay. Well, let's divide both sides here by B, divide both sides here by A, oops. Okay, both sides by A and both sides by B. Here the A's go out, here's the B's go out, and what does that leave you? And it doesn't matter which order you do. The way I did it is sine A over A is equal to sine B over B, which is exactly the same as A over sine A is B over sine B. That's how we get the law of sines. Now, what if you had dropped your perpendicular this way? So the height of this triangle is perpendicular to BC. Then you have the relationship between B and C, and this will be a different height, by the way, but that's okay. But you still get the relationship that will be just like this. Sine B over B is equal to sine C over C. So that time that ratio is the same as this ratio, so all the three ratios are the same. And it doesn't matter who you put on top. Okay? You can put the length on top and the sine A on the bottom, or you can put sine A on top and length on the bottom. Because none of them are zero, right? That's not much of a triangle if one of the sides is zero or one of the angles is zero. It's not a triangle. So you can't use law of sine for that. Okay. Now that's for an acute angle. What about for an obtuse angle? This is also an oblique triangle. Well, here you might talk about the sine of A here. Okay? Well, the sine of A here is the same as the sine of this angle here, isn't it? Because sine is opposite over hypotenuse. And the opposite side for this angle is the same as the opposite side. Yeah, those are the same opposite side. That's the side right there. So yeah, this will still work the same way. You can do the same with B. The side opposite B would be this one over, yeah. So it works exactly the same way. It doesn't have to be acute or obtuse. The law of sines works for the same. Now, like I said before, you can also write it in the reciprocals. Sine A over A is equal to sine B over B is equal to sine C over C.
How come you can't do it like from angle A to the H?
Say this again now.
How come you can't do the H from angle A?
You can. That's how you get the third one. If you do the H this way, it's a different H, but you do that, okay? And then you get the sine of C is equal to H over B. And the sine of B is equal to H over C. And then you rearrange them and you get the same ratios. Yeah, you do. That's exactly how you get the third one. The way I did it only gives you this first two ratios here. It doesn't give you C. And in fact, you have to do this one. It's a different H, but the ratios are the same. Those are equal again. So all three of those ratios are equal. No matter what size your three angles are. Okay. Now I say that, no matter what size the three angles are. Later we will see there are certain times you always want to maybe do the big angle first. Okay? Because almost the very reason that we're talking about, the sine of this angle is the same as the sine of this angle. So those ratios will be identical here because the H is the same for both the acute angle triangle and for the obtuse angle. So you have to nail down the one which is the biggest one first. We'll talk about that when we get to it, okay? But the formulas are identical. So here's a triangle. For the triangle in this figure here, 6.1, they gave you angle C is 102, okay? Believe it or not, that's obtuse, okay? All right. Angle B is 29 degrees. And the side B is 28 degrees. Find the remaining sides, angle, and sides. You got three that you know, three that you don't know. Which is the easiest thing to calculate first? It really doesn't matter, but what's the easiest one to do first? Require the least effort. The lazy one. Yeah, find angle A. How do you get angle A? Second? Yes, you do. What? Not 90. This, yeah, 180. The sum of the three angles of any triangle, whether it's right triangle, oblique triangle, any triangle, it's going to be 180 degrees. So this will be 180 degrees minus, you can either add those two together or subtract them twice. I don't care. I like to add them together. That's 102 plus 29 would be 131. And that would be 49 degrees, if I did it right, right? Got one of them done already. Pretty simple, right? What's that? Did I do it right? I may not have. I'm doing it in my head. Say again? Yeah. If I had a calculator, I would just do 180 minus 102 minus 29. 49. Good deal. Okay. Now, you got one of the three unknowns already solved. So how do we go about getting the others? Still missing little a and little c. Okay. Now, here's my little...
Oh, you want to do the given one?
Second?
You want to do the given value?
Yeah, I like to use the given ones, because what if I made a mistake on this one? Then guarantee I'm going to make a mistake on the other two. So I like to have the ones that are given. And what I always look for, with law of sines, you have to have it, by the way. You have to know one ratio. Let's go back to this again. Notice what we have. This ratio is equal to that ratio is equal to that ratio. You're dealing with ratios. So what I always like to do is write down the one I know, the ratio I know. And the ratio I know is these, the B's. So I write that down first. And I don't care which one you put on top. But whichever one you put on top, keep that same pattern. So what you want to do? I don't care. You tell me, how do you want to write it? Okay. Sine of 29 degrees is to 28. That's going to be in feet. As, and you can write down either one of the other two you want to. Sine of what? Okay, sine of 102 is to little c. All right? When you got 3 out of 4 on a ratio, you know the other one, right? So that's why I always write down the one I know and then pick one of the ones I don't know as the other. All right? Now, there's a couple ways you can do this. I like to just cross multiply, okay? And say c times the sine of 29 degrees is equal to 28 times the sine of 102. Now, before I start punching in numbers, I like to go on the divide by sine of 29 degrees. Goodness gracious, I can't write. Okay. And these go out then, and there's your C. Now, if you don't like to go through the cross multiplication, you can do this. Here's the thing you're looking for. Put this product on top, that thing on the bottom. Okay? You can just write your ratio down like this. 28 times the sine of 102 divided by sine of 29. Okay? And if you got your calculators, punch them in and give me an answer. By the way, we in the South are pretty violent. You know, we always punch things in. We don't press them. When I lived in Nebraska, people made fun of people from the South. You get on the elevator and say, punch 9. We press it. Okay. So they don't punch things. So we're violent down here. Okay.
How many decimals do you round it to?
All right. Good question. I look at this and say, I don't see, look at what they give you. 2 digits, 3 digits, 2 digits. Go for 2 digits. You can't get more precision out than you put in. The book gives you way more. I say go for 2 digits, whatever that will be. And what will that be? Second? 57. 57, and that will be feet, right? Okay? Now, I always stop and ask myself, does this make sense? Okay? Here's something about geometry. Always the shortest side is opposite the smallest angle. This is the biggest angle. This had better be the largest size. It looks like it anyway. This thing better be greater than 28. It is. Now, that's all we can say. It's the right magnitude. It's the right comparison. You can't say if the number's correct or not, but let's go from that. So you got two out of 3 of the unknowns. This is approximately 57 feet. Okay? How do you get A?
You said B equals
Yeah, again, do your one you know. Sine of 29 degrees is to 28, as this time we'll do sine of 49 is to A. Don't tell me we're already... Oh, how did it happen? Okay, let's finish this one quickly. So A is equal to the product of these two, 28 times the sine of 49 degrees divided by sine of 29 degrees. So I'm going to punch that in pretty quickly. What's that? 44? Okay, about 44 feet. Okay, So this would be about 44 feet. Okay? Again, does that make sense? 49 is greater than 29. 44 is greater than 28. Both of those are less than 57. Oh, yeah. Yes, it is. Let's see very quickly how they did. And that will be, I didn't need to do that. They first got the angle, which is 49 degrees. Law of sines, they got A equal 43.59, which is 44 feet, and C is equal to 56.49, which is about 56 feet. Very good. We'll pick up with example 2 next time. Homework exercises here. You can just barely get started. Do either of the odds 5 or 7 or both. And you can start looking at the odds 9 through 23 if you'd like. Okay. We'll pick up and go with example 2 next time.